Hi friends, welcome to our channel Vidya Vihanga. As a part of machine learning with Python, we have covered the most important library, NUMPY, which is the basic linear algebra library, and now we are going to start another important library, Pandas. Now let's get started. Pandas is an open source library which is built on top of NUMPY library. It allows us for fast analysis, data cleaning, and data preparation. Data preparation refers to filling some of the missing data with the available data in our dataset. Data cleaning refers to removing some of the categorical columns which are not useful for us in the dataset. It excels in performance and productivity. It has built-in visualization features and it is capable of taking up input from various variety of sources like CSV, Excel, etc. and convert them back to CSV, Excel, etc. after training our model. Now let's jump into Jupyter Notebook and try to implement some of the functions in the Pandas library. Now I am here at the Jupyter Notebook and let's get started. Initially, I am importing a NumPy library and I am giving it an alias name as NP. And in the similar fashion, I am importing the Pandas library and I am giving it an alias name as PD. I am considering two variables. Initially, I am considering a variable labels and I am taking a list of elements A, B, and C, and another variable as my underscore data, and I am taking the elements 10, 20, 30. My labels and my underscore data and labels are the two variables which are consisting of a list of elements to be simple, and I am using another variable ARR and I am converting that into an array with the variable my data, and I am even considering another variable D and it consists of a dictionary of elements A with 10, B with 20 and C with 30. Let's run this. So initially I want to see what is present in ARR. ARR consists of an array of elements 10, 20 and 30. Now pd dot series of my underscore data comma labels. Let's run this. So series is a main function in the Pandas library which we'll be using most of the time. So what we have done so far is that we can see from the output A with value 10, B with value 20 and C with value 30. So the labels which we have mentioned as the second argument consists of A, B, C are taken as the indexes. So A, B, C are the indexes here, and the my underscore data which we have passed in as the first argument, which consists of the values 10, 20 and 30 are the values. So the second argument which we pass is always the index, and the first argument which we always pass is the values. Let's explore much on this series function. Let's give the argument labels. Now, by default, the indexes will be 0, 1, 2, and the values now are labels. So the labels variable present consists of A, B, C as its values. So the indexes are 0, 1, 2 and the values are A, B, C. In the similar way, we can even replace this with my underscore data even. So here we go. The indexes will be 0, 1, 2 by default and the values will be 10, 20 and 30. And now let's consider two variables. First of all, I'm considering one series ACR1 and I am passing some values to it 4 and I am passing some country names to it. And I'm taking another variable SCR2, and I want to modify these a little bit. Now I am replacing Germany with the USSR. Now let's run this. Now let's see what is present in SCR1. So here we go. These are all the countries are the indexes, and the values are as the first argument. 1, 2, 3, 4 are the values. In the similar fashion, let's see what is present in SCR2 even. Here we go. These are country names as the indexes, the corresponding as its values. Now let's perform a small addition operation between these two series. I'm using a addition operation for these two series. Let's run this. Let's try to understand what is going on here. In the first series, Germany is present in the first series but not in the second series. So the system doesn't know with which index it has to add this value, as Germany is present in the first series but not in the second series. So the system doesn't know with which index this 3 has to be added with. So it will be giving a NaN value. So if we consider the case of India, it is present in the both series 1 and 2. So it adds the number value 2 with the 5. So it will be giving us a value of 7. It converts these integers into floats because in order to retain all the information. If we consider the case of USSR even, USSR is present in series 2 but not in series 1. So the system doesn't know with which index it has to add it. So it will be giving a value of NaN. Now let's move further. I'm using another variable df, and I am introducing you to a new function data frame, which is much important while we are using the Pandas library. And I am giving some of the inputs to it as B, E, and F. Let's run this. Oh, I haven't imported random function, so let's do that first of all. From numpy.random random. Let's do this now. Yeah, that's it. Let's see what is present in df. So data frame, usually we use data frame function whenever we want to align all the elements or all the data into a picture clear of rows and columns. Here the random of 3, 3, that means it is 9 elements is the data or the values, and A, B, C are the indexes. A, B, C are the indexes right here we can see, and D, E, F are the columns. Here we can see that. And now we will perform some operations, or we explore this data frame a much more further. Now what if we want to extract a column of this? It's very simple. df of E. We'll be getting an output of the column E. Now what if we want to extract 2 columns at a time? It's even simpler. Simply we have to mention the 2 column names. So we have extracted the columns E and F both at a time. And now I want to add a column, a new column to it. So I am adding a new column which is named as add. Now I am adding the columns D and column E. Let's run this, and now let's see what is present in this column EDD. This is a new column. So here we go. This is the summation of these two. We can check it out. As of now, I am not doing that. Now let's see what is present in DF. So in the DF itself, a new column named with add is being added. This is a new column which we have performed on our own interest, but this is not our actual training data set. So this will be affecting our training model. So let's try to drop it off. Now I want to drop this particular column add. For that I'll be using the function drop to it, and I am specifying that column name, and I am using this as axis 1. So let's drop that column. Here we go. We have dropped that new column add. Why I have mentioned this axis is equals to 1 is that axis equal to 1 indicates that it is a column add. If we don't mention this axis is equals to 1, this 1 indicates for columns, and by default, if we leave without mentioning this axis is equal to 1, it will be considering axis is equals to 0. 0 refers to rows. Now let's try to run this event. Here we go. We got an error. Add not found in axis. As we haven't mentioned what is its axis, the system checks in the rows A, B, C, but I haven't found any row with name add. So what do I do? So that is the reason why we have to mention whenever we are dropping a column. So now we have back to that. We have dropped the newly added column add. Now let's see what is present in DFF again. Oh, still the column the newly added column add is still present. It hasn't been dropped. Now what to do? Simply we have to add another argument. In place is equals to true. This argument indicates that this should be placed, or this should be happen further permanently. If we run this now, let's try to see what is present in DF now. So here we go. The newly added column add is gone for permanently. If we haven't done this, every time we try to model our training data set, a new column will be taking place into the picture. So in place is equals to true should be done for every time. Until now we have seen the operations on the columns. Now let's try to see to perform on rows. df.loc of A. So here we go. The values present in the row A, minus 1.5, minus 1.2, and minus 1.3. So here we go. Even this comes in a data frame. So data frame beauty is that every time it will be indicating that in a particular neat rows and columns with an index and values. Index and values. In this particular situation, D, E, F is the index and the values are those. Similarly, we can extract even the same result with the indication of the index event. Let's run this. So we can see here the output for these two statements is same. So what is going on here is that location of A, so it is locating the A row, and I location, index location. So A is present at the 0th index, so I am using the index location 0, so it will be taking us to the same output. So these conditions can be used vice versa, anything we want. Now what we want to extract is subset of this particular data frame df. I'm extracting A and B as rows and B and E as the columns. Now let's run this. So here we go. We have got a subset of the main data frame. Moving forward, let's try to perform some other things. Now I am using df greater than 0. So here we go. We got a boolean numbers as for true or false. If we observe the data frame df, there are some negative values, some positive values, right? So if we perform df greater than 0, it clearly indicates which numbers are greater than 0 and which numbers are less than 0 by giving true or false. Usually we won't be interested in what is true and what is false, but will be interested in the values, right? So for that, we'll be simply modifying that above statement as like this. So if we run this, so here we go. The numbers which doesn't satisfy this condition will be indicating as no integers, and the values which are satisfying this condition will be present. So here we go. The trues in the above statement, the true with the conditions where true is present, we'll be getting those values, but not for the others, right? Now, what if we want to apply this particular condition to columns? Now I am applying to the column D, and I will try to execute this. Okay. Now what we observe is that if we perform this particular condition to a particular column D, we'll be getting the numbers or the rows to which this condition is satisfying. As A doesn't satisfy this condition, df of D greater than 0, so the row A will be deleted off. Only the rows which are satisfying this above condition will be present. Now with that, let's move further. I still want to do some more operations on this by using E. Now let's try to run this. Here we got only the E column. Why this happens is that here we are mentioning the condition for the column D, and if the particular row doesn't satisfy that condition, the other two rows we got as the output, right? Now, but in this particular statement, we have mentioned it clearly that only I want the column E. So it will be checking the condition for D column, but it will be giving us an output for the column E. That's it. So that's the difference between these two statements. Now moving forward, I want to use the reset underscore index, which introduce a new column of indexes. Let's try executing this. Here we go. Besides A, B, C, we are getting another index as 0, 1, 2. So usually reset index will be using for in such cases. Now another thing is that now I want to perform two conditions for the two columns. For that, let's indicate the first column D such that it is greater than 0, and I'm considering second column E even that should be greater than 0. So now let's try to run this. Here we go. From this, what we came to know is that it is checking on two conditions such that D, the column having the values greater than 0, and the column values E also greater than 0. So that is nothing but the 0, which is consisting of greater than 0 values for the both columns D and E. Let's move forward. Now I will be introducing you to the missing data. So this we have referred as the data preparation, right? So let's see what this missing data is and how we can prepare the data from the data set for the missing data values. I'm using a variable D and taking a dictionary A which has a list of numbers and another element is B such that it consists of an elements 5, and 9. And I'm considering another element C. It consists of a list of elements 1, 2, 3. Now let's run this. Now let's see what is present in D first. So yeah, here we go. Obviously that should be right. Now I'm converting this into a data frame and I am using a variable df for that. Data frame of D. Now let's see what is present in df. So here we go. It has been arranged into nicely rows and columns. Now, as we can observe here, there are some missing values. If we consider the first row of second column, it is missing. The second row of A column, it is missing. Second row of B column is missing. So now we want to fill out these particular elements with some of the other values. Now let's try to do that. Before that, what if we want to drop the not present values or the non-integer values? So df dot drop any. So here we go. So the rows which is having integer values will be dropping off. So only the first row is having all the integers. So the output will be the first row itself. What if we want to drop a column in the similar fashion? We simply mention it as axis is equals to 1. In this case, the C column is having the values for each and every row, so the output will be the C column. If we haven't mentioned this axis, then it will be row. If we mention this axis equal to 1, then it will be column. That's the difference, that's it. Now, what if I mention to this a threshold value of equals to 2? Now let's try to run this. Oh, sorry, I have run PH. Yeah. So here we go. What we have understood from here is that this is our main data frame df, and this is when we include it a value of thresh equal to 2. Thresh in the sense threshold. Threshold is equals to 2. Only when the threshold value is 2, then it should be drop off. If it's less than 2, then it will be retaining. So for the first row, there is only one such non-integer element. So that particular row will be present. For the second row, there are two non-integer elements. So that particular row will be dropping off. Next, I am filling these non-integer numbers with fill NA with the value is equals to some 7, I say. Let's run this. So all the elements with the non-integer values are now filled with 7, as we can see here, right? What if we want to perform some operations on this particular one? In the sense, what if we want to include these elements with some of the operations with the present dataset elements? For that, let's consider A and fill that with the value is equals to df of A dot mean. Let's run this first. Okay. Now, what we have done so far is that now we are trying to fill the values present in the column A. Let's see what is present in df. Yeah. So, just we can compare from here now. In the original data frame df, the column A has 1, 2 and non-integer value, right? So what I am trying to do here is that I want to fill that particular A column with the mean of the other two numbers. So I am using the column A to fill with the value of df of other elements A of mean. So 1 plus 2 by 2, that's nothing but 1.5. So I have filled the other element as the mean of the other two elements. In the similar way, we can take out not only the mean, some sum, difference, or whatever on average, and anything it may be. We can fill out these values with the other elements present in the dataset. So this is known as the missing values or the data preparation. And this dropping of access is known as data cleaning. In this case, it's not necessary, but data preparation, data cleaning will be necessary when we are dropping off the categorical columns that I'll be showing you in the next videos. Now, so this is the beauty of using the Pandas library. Pandas library is, as we discussed, is really important for data cleaning and data preparation. With that, I conclude for this video. Please like, share and subscribe to our channel Vidya Vihanga.